Let's take a look at the quadratic formula. The good thing about the quadratic formula is it can be used to find solutions to any quadratic equation. And we may end up with real or non-real complex solutions. So let's take a look at some examples. So first we're going to use our standard form to find the discriminant that we've already talked about. So in example 1, we have A would be equal to 1. B is -4, and then C is 4. So I'm going to first find the discriminant because then it will make my quadratic formula easier in just a minute. So I have B is -4. Sorry, my pen is not cooperating. There we go. -4 squared minus 4 times A, which was 1, and C, which is 4. So then we get 16 minus 16, which is 0. So we're going to take that and plug it into our quadratic formula. So notice here is our formula, and we're going to plug it in underneath the radical because we've already found the discriminant. We don't need to find it again. So x will equal -b, or opposite b, which would be +4 for this example, plus or minus the square root of our discriminant, which we've already found is going to be 0, over 2 times A, and A was equal to 1. And so then we just have to clean that up. So x equals 4 plus or minus, and then the square root of 0 would just be 0, and then all over 2. And then whether you add or subtract 0, it's not going to change the 4. And so then you end up with 4 divided by 2, which is 2. So notice x just has one real root of 2, which goes with our discriminant value, which was equal to 0. All right, so let's look at another example. Example 2, we need to first put into standard form. So we need to move the 3x and move the 5 over to the left. So then we end up with 2x squared minus 3x minus 5, where A would be 2, B is -3, and C is -5. And then work on our discriminant. So B squared minus 4AC is our discriminant, which would be -3 squared minus 4 times 2 times -5. I'm just plugging in the B, the A, and the C value, and then I'm going to clean that up. So -3 squared would be +9, minus 4 times 2 is -8, times -5 would be +40. So we get 49. So we know if it's positive and it's a perfect square, that we should have 2 real rational roots when we do our quadratic formula. So let's plug it in and take a look. So x equals -b, so negative or opposite b would be +3, plus or minus the square root of our discriminant, which we've already found is 49, all divided by 2 times a, which is 2. And see, it makes your quadratic formula a lot smaller now that you've already done the discriminant ahead of time. And so x will equal, we just need to clean it up a little bit, 3 plus or minus, and then you have the square root of 49, which is equal to 7. It comes out evenly, over 2 times 2, which is 4. So then we need to separate those two and keep simplifying because we can. So we want to say 3 plus 7 divided by 4, which would give us 10 over 4, which is 5/2. And then we also need to do x equals 3 minus 7 divided by 4. So 3 minus 7 is equal to -4, divided by 4 equals -1. And so then we have x equals 5/2 and -1. So notice those numbers are 2 real rational roots. Rational means they can be written as a fraction. Write that down.